This is McGraw-Hill Chapter 7, Section 4, Graphs of Quadratic Functions. All right, and what we're going to go over here is three different transformations of graphs. The last section, Section 5 of Chapter 7, deals with putting all three of these together, and so does the last example problem. First transformation is, of course, where we have a number, which we're going to call k, which ends up being a y, plus or minus to your x squared. Okay, see how the number is being added directly to the x squared. And remember, x squared is quadratic. When your highest power is to the second power of your variable, it's a quadratic. So here's an example. We have the graph of x squared, which is right here, and the ordered pairs are 0, 0. If you plug 0 in here, you get 0, 0, and you get 1, 1. Negative 1, 1, and you get 1, 1. If we go to the next graph, we have g of x equals x squared plus 1. Well, what we're going to do is whenever we have this situation, we're going to add 1 to all the y's. So I'm going to add 1 here to 0, 0, so it now becomes 0, 1. I'm going to add 1 to this y, so now it becomes 1, 2. I'm going to add 1 here, and so now it becomes negative 1, 2. And so there's my graph. On the h of x equals x squared minus 2, here we're going to subtract 2 for y. But this from the original graph. Okay, so I'm going to subtract 2 from here, so now it becomes 0, negative 2. I'm going to subtract 2 from here, so it becomes 1, negative 1. I'm going to subtract 2 from here, so it becomes negative 1, negative 1. So there's my graph of x squared minus 2. Okay. So that's what's happening whenever you have a number added or subtracted directly to the x squared. Okay. The next transformation we have is where we're adding directly to subtracting directly to the x. So see the difference here. And we call this h. Okay. So h right here is being added or subtracted directly to the x. It's not the same situation here where k was added or subtracted to x squared. Now, this becomes the difference that you got to look at, because if the number is being subtracted from h, it's a movement to the right. It's the opposite of what you have here. And the reason it's the opposite is because if we have x minus h squared, then if I pull that x minus h out, set it equal to 0, then x becomes positive. So whenever you move on these particular types of problems here where you have an h, it's always the opposite of what the sign is. So again, here's our problem. We have f of x equals x squared, or we have 0, 0, 1, 1, negative 1, 1. So here's our base graph. And we have in blue g of x equals x plus 1 squared. See, this plus 1 is directly with x. See, over here, it was with x squared. So what this means is we're going to subtract 1. We're going to do the opposite of this sign. So we're going to always subtract 1 from x when this situation happens. Nothing happens to y. So if I subtract 1 from here, I'm at negative 1, 0 from x. If I subtract 1 from here, I'm at negative 2, 1. And if I subtract 1 from here, I'm at 0, 1. So there's the blue graph. Here we have h of x equals x minus 2 squared. So it's a minus, so we're going to add 2 to x. So I'm going to add 2 to this x here, so I get 2, 0. I'm going to add 2 to this one, so I get 1, 1. I'm going to add 2 to this one, so I get 3, 1. And there's my graph there. Okay. The other transformation that takes place is when you have a number in front of x squared. Okay. So, if you have a number that's greater than 1, then it's called a vertical stretch. So it causes the sides to come closer together. In other words, to rise faster. If you have a number in front of x squared that is somewhere between 0 and 1, which means a fraction or a decimal, then it causes what we call a compression. So it causes the sides to move down. Okay. So here's example 7 on page 2619. Now, notice we have 2 times x minus 3 squared plus 4. Okay, so let's take care of this first. So that means that from 0, 0, it's going to move up 4. And then this negative 3 minus 3 is a plus, so it's going to move to the right 3. So our vertex is at 3, 4. Then what happens is that just go from your 1, 1. Just add 1 here. Just take away 1 here and add 1 here. So we're at 2, 5. Now add 1 here and add 1 here, and you're at 4, 5. So see, what I'm doing is, if you look at this, I'm finding my vertex first, and then what I'm doing is I know the next ordered pair should have been negative 1, 1. So I'm subtracting 1 from the x, add 1 to the y. That's how I got this 2, 5. And then on the second point, it should have been 1, 1. So I'm adding 1 to the x and adding 1 to the y. The 2 is a vertical stretch, so all I'm doing is just drawing a kind of representation of how this would change. And that's all I want to see when there's a number in front of the x squared. I just want to see it stretch. If it's larger than 1, I want to see if it compress, if it's a fraction or a decimal. Okay? So we'll talk more about this in class, but basically what happens is it's all dealing with the ordered pairs, and it's all dealing with the general graph, quadratic graph, which is these 3 main points, negative 1, 1, 1, 1, 0, 0. And that's how I got these points here. But remember, I did my vertex first, and then from my vertex, I subtracted 1 and added 1, which is that negative 1, 1. Then I added 1 and added 1, which is that 1, 1.